Welcome back to the kitchen for my fourth and final installment in my series Getting Started with Basic Electronics for Beginners as it pertains to do-it-yourself guitar effects. I took kind of an unorthodox path to arrive where I am today, which is not to say that I'm an expert or a pro, but I've been able to accomplish my goals, which isn't really saying too much because I haven't set my sights too high, but I have relished and really enjoyed the experience as I went along. Breadboarding is the topic of this final video. I'm going to be highlighting a project that I breadboarded that I ended up boxing up and I use in my pedal board, and it was an invaluable experience because it provided me with understanding of the circuit and basic understanding of the individual components and the functions that they serve in the circuit. I'm not going to get into too much detail on that end of things. I feel that it's better for you to go through this experience on your own and learn it in your way, and therefore it will stick. But I wanted to give some breadboard basics for those of you who have never had one in front of you, and then show off the circuit a little bit. So let's take a closer look at my breadboard. So taking a look at this already populated breadboard, well, one thing that all of these circuits are going to have in common, they all need to be powered somehow. So here I have connected a 9-volt battery clip, and it runs up to these convenient binding posts. This wiring comes up here, and I used an orange wire run to my positive rail and a black wire to go to my negative. You notice that there are 3 of these binding posts. Well, some of the more complicated circuits run off what's called a bipolar power supply. You could think of that if you took 2 9-volt batteries and connected the plus and the minus with each of one of those batteries together. That would become the ground. Left over, you would have one plus 9 volts and one minus 9 volts. That's a more complicated bipolar power supply, but most of these guitar pedal circuits only run on a standard 9-volt plus minus power supply. So you could see here, to power the circuit, I could just grab a 9-volt battery, plug that in there. But you know, this particular circuit, and often you'll find you're gonna be spending some time with this, and I'm cheap, I don't like wasting batteries. So what I did, I got this little clip adapter, and so there's an additional 9-volt battery clip, connects onto this one here, and that goes to a 2.1 millimeter DC power connector. So I could just grab a battery eliminator and go ahead and plug that in, up until about the time when I'm really wanting to do a full test. Because see, sometimes these battery eliminators can add additional hum or noise issues, so I like to always keep a fresh 9-volt battery around just to see exactly what's going on with the circuit and make sure that there isn't any additional problems being brought on by a power supply. Another thing that obviously all these circuits are going to need is wire. So I took a look on eBay, and if you look up breadboard jumper wire kit for just a few dollars, you know, it's like about $3, 40 cents of shipping. You can get a 140 piece kit with a plastic box. I think there was 40 cents shipping on that one. These are all different color, all different lengths, color coded. They are a little bit difficult for me to pull out of especially the real small ones. So I like to use a needle nose to get them out. You can see that's a real small little guy there. Or you know what, if you were really frugal and you wanted to save yourself some additional money, grab a few pairs of side cutters and some wire strippers or lighters and sit down in front of the TV with your friends and family and have a little stripping party. Now, getting your guitar signal in and out of the breadboard, what I've done here is cut down a small plastic container and drilled it out. I added a 1/4-inch female guitar connector jack. So this would go either to the guitar or maybe to the amp. And then I got a couple of leads coming off of that. It's soldered. Now, the thing about this wire is it's a little bit large. This is maybe, I don't know, 18, 20 gauge wire, something like that, that's been soldered. And if I were to force this, I could get this into these slots. It's just a little big. So usually what I do is I'll cut a small piece of solid gauge wire that's been stripped. Then I'll solder that on there, just an extra little extension to make it plug in and out very easily. I removed those recently. I was testing this out on something else, so I'm going to have to hook them back up. The point is you really don't want to force anything into your breadboard. Once you do that, that slot's never really going to be the same. You don't want to break anything off in there or just widen it out. Some of the leads on the resistors are awfully skinny, so leaving them as they are, it's important not to force anything in or out of your breadboard. Now this circuit here, first off I did an LPB1 and I did a Smalley boost. You can see some of these wires it's a little bit neater than other areas. You really want to try to keep things neat, especially if you're going to be changing components out all the time. This was like a real stock design, same with this. I didn't really monkey with it too much. This area here was where I was interested in trying out different components, so I tried to make that a little flatter, keeping everything nice and neat. You really don't want a spaghetti monster on your breadboard. When you're just starting out, you know, like you don't need these fancy adapter clips and all this stuff. It's just kind of whatever you're comfortable with. You theoretically, if you have extra 9-volt adapters, you could just cut this sucker off here, use your multimeter to determine which wire was positive, and then connect those right into here. You could, you know, and this brings me to a point. If you've never done any breadboarding and you're an absolute beginner when it comes to electronics, well, grab yourself an LED and maybe a 1K or so resistor. You don't want to directly connect a resistor to DC current, like 9 volts especially. It's going to blow that LED up. So you use a current limiting resistor. This way you could set up a little mini circuit just to, you know, get yourself familiar with plugging wires in and out of the breadboard and how it works. And also you can use that as a continuity tester. My meter has this feature built in on it, as many other meters do. Because one of the things that's important is checking out your rail. You can see here I have my power coming in, and I used an orange wire to come to this red line here. That's like my positive rail. It runs all the way down the bottom. Wherever I need a positive 9-volt connection goes right down to there on my schematic. Same thing with the ground, or the minus. Whenever I need ground, I can get it right down here. And as you can see, I've got these additional circuits on the north end of the board, so I went ahead and ran some extension wires coming up here to activate my top rail and a middle rail as well. This board has a total of 4 horizontal rails for plus and minus or ground. In this circuitry, I'm only using, looks like 3. I think I had an additional wire in here that was removed at one point. I pulled the germanium diode out of the circuit. I must have used it because those are kind of rare. I don't have a real lot of them. So I'm going to have to put that back in there if I fire this up again. Back to my little LED test circuit. Just to demonstrate very quickly, I'm going to put it back on this continuity test where when we connect the leads, we hear a tone or the music. And I wanted to show you exactly how the breadboard works. It is connected vertically. So this is row, what row is that? Row 50. I'm going to go ahead and insert one in 50 at the top, and then at the bottom you can hear the music. Now if we go, there's a dividing line here, so if we go down here on 50 we hear, oh, we're not getting any music. Well, why is that? That's because there is 2 cutout lines where it does not pass through, and that's for inserting integrated circuit chips, or in this case I have what's called DIP, or very tiny switches. That's where we put our IC chips. They hook up on those cutouts where there is not any vertical connection. But all the way through this breadboard, I'll use my handy dandy pointer, these are connected vertically all the way through from 1 all the way down to 65, I believe it is. Same thing with this whole section in here, this section in here, this section in here. connected vertically. Now, our rails on the bottom, well, that varies from board to board, but this particular one, they connect all the way through. And what I was going to mention right off the bat, it's important to check out your breadboard and see if it's connected all the way through. So I'm going to go ahead and, yeah, we got it there. And we'll try it on the positive rail up here about in the middle, see how far we go. Yeah, well, some of these, they have a break in the middle. Some of them, this one in particular, it has, go ahead and try it here, and then all the way at the end we get nothing. So we go over here to 3, they're connected in sets of 3s. If I go over here to 4, I get nothing. Well, I'll move it over here to the end of the 3rd set, and there you go. So I would want to go ahead and use a small wire to jumper, like so. If I was going to use this full breadboard, you know, at this point, now I'm connected from, you know, 1 all the way down to about over here. And if I wanted to, if my circuit ran all the way down there, I would indeed need to utilize another jumper in here to connect that to go all the way through. If you're just starting out and you don't have a meter with a continuity test or anything like that, well, then you could go ahead and use your 9-volt battery and an LED. And current limit resistor is a necessity with an LED, so you do need a resistor. But you could whip up a quick little test where come up with a couple wires. When you connected those, it would turn that light on. That would serve as your continuity tester. You could build this circuit and indeed go ahead and test your rails and see where you're at with that as your first breadboard project before you move on to something like, well, perhaps the NPN boost or an LPB1 or a bass fuzz or an ADA flanger.